All right, we are almost finished with this unit. We have a few more lessons to go. This is lesson 12, where we're talking about methods of heat transfer. And in the previous lesson, lesson 11, we talked about thermal energy and how thermal energy always moves from the higher temperature object to the lower temperature object. And we looked at some examples of that. If you were in class, we did some fun investigative work where we looked at some different comparative objects' temperatures. And we saw that every time two objects had different temperatures, we saw that the heat moved from the higher temperature one to the lower temperature one until equilibrium was met, which helped solidify that principle that we talked about. In the lesson 10 PowerPoint or Google Slides presentation, we talked about heat and temperature and how even though they're different, they relate to one another, because when you increase temperature, that is a direct correlation to how much heat energy is in a system. So an increase in heat energy will also increase temperature, or an increase in heat energy increases kinetic energy, which again will increase temperature, and then vice versa is true. So we've been talking about heat and temperature and heat energy, how it moves, and today we're going to look at some specific ways that heat energy moves, and we're going to talk about some things that you may or may not be familiar with, but we're going to go through, get some quick definitions down, and some examples. So if you'll look here, it says, think of 5 examples where heat energy is transferred in things that you do every day. So pause the video and just do a quick jot down of some things that you can think of. So you may or may not have had the same examples as me, but water being heated for your shower. I don't know about you, but I do not like a cold shower, so I definitely want my water to be heated. Every morning I cook eggs for breakfast. I don't want my eggs to be raw, so to get cooked eggs, I've got to have some heat. So I do use heat to cook my eggs. Water freezing into ice for hot beverages. Dew evaporating from the grass when the sun hits it. That would be an example. Tons of examples. We just want to get to thinking about heat energy and how it can transform or change the temperature of an object. So we do know that thermal energy transfers happen all around us, and they happen in 3 forms. So we have conduction, we have convection, and we have radiation. And these are pretty simple, so we're just going to go through and get some definitions and examples of each. Just be sure that you have these in your notes as well. All right, so starting with conduction. Conduction's the transfer of energy between 2 objects that are in contact with one another. So when 2 objects touch and there is a transfer of heat energy from one of those objects to another, then we have conduction. So if you'll remember, conduction is going to happen in solids. So when heat moves through solids, that is conduction. So let's assume this is some sort of conductive material here. We've got the Bunsen burner, and you can see how the Bunsen burner generates heat energy, and that heat energy is going to move through the conductive material. So if this conductive material is a solid, which I'm going to assume that it is, then we have an example of conduction. So what happens here is the heated particles. Remember, all matter is made up of particles. Those particles are constantly in motion. And so we can see that here. So when one molecule or particle heats up, it collides with the next, which transfers that heat energy from one side of the conductor to another. So a couple of examples of conduction. A metal spoon gets warm as you stir a hot bowl of soup. This would be heat moving through a solid, so that would be conduction. Metal coat hanger gets warm when roasting marshmallows. So if you have ever used a metal coat hanger to roast marshmallows, you know this happens. You cannot hold it for very long before it gets really hot. That's also an example of conduction. Now, convection is going to be the transfer of heat energy through liquids and gases. So always ask yourself in an example, is heat moving through a solid? If it is, it's conduction. And if heat moves through liquid or a gas, it's going to be convection. So the heat travels in the same way, but it takes a lot longer in liquids and gases for heat to be transferred, because remember, in liquids, the particles are not side by side. They're a little more spaced out. And in gases, they're even more spaced out. So when one molecule gets heated, it takes a little while for that heat to be transferred. A couple of examples of convection: heat leaving a coffee cup as steam rises. So if I'm looking at something warm and I see steam, that heat's going to be moving through a liquid and then through a gas. So that would be convection. If you're looking at the example of regions near the equator, they're warmer because that warm air from the equator spreads out over the equator. That would be an example of convection. Also in the picture at the bottom right of this screen, you have a fireplace. It's transferring that heat energy. Warm air moves up, and because it's less dense, so it's going to move up and then it's going to circulate. It's going to become more dense as it cools and falls, and this creates what we call convection current. But you can see that heat energy is moving through the air, and anytime heat moves through liquids or gases, that is an example of convection. Now, radiation is going to happen when heat is transferred through electromagnetic waves. So we've talked about waves. We've talked about electromagnetic waves. So if heat is moving from light waves or through light waves, through UV rays, through infrared radiation, microwaves, gamma rays, or any other part of the electromagnetic spectrum, this is an example of radiation. So if you're lying in the tanning bed, which I do not recommend, but if you are, and you feel that warmth, that is an example of radiation, because the tanning bed is putting off those UV rays. Another example would be sunlight heating the pavement. So that sunlight is coming from space via the electromagnetic spectrum. And so that would be an example of radiation. If food is being heated in the microwave, microwaves are part of the spectrum. So anything that is being heated by any component of the electromagnetic spectrum, that is an example of radiation. Another thing I want to point out here while we're talking about heat energy is the difference between conductors and insulators. We touched upon conductors and insulators when we talked about electricity, but now we have a definition. So, conductor, any material through which energy can be easily transferred. So an example would be metals. Metals are great conductors of heat and electricity. Gases, on the other hand, are very poor conductors because their particles are too spread out. Now, great insulators would be things like rubber, wood, some fabrics. So think like an oven mitt. Some liquids can also be good insulators, but insulators are any material where energy or electricity cannot be transferred very easily. Doesn't mean they can't be transferred at all, but not very easily. All right, so wooden spoon, would you say conductor or insulator? What about a styrofoam coffee cup? What about the copper in this set of copper wires? What about the cooler? And the paper clip? All right, so let's go back through and see if you guessed correctly. So the wooden spoon, hopefully you said insulator. The styrofoam coffee cup would also be an insulator. The copper wire, this is going to be a conductor. And then now if we were specifically talking about the outside of the copper wire, that is an insulative material. The cooler is going to be an insulator. And the paper clip is going to be a conductor. All right, so that ends our lesson on conduction, convection, and radiation. Your teacher should have this worksheet for you. So when you end this video, I want you to get some practice over the different types of energy transfer with this worksheet. And I will see you in the next lesson where we talk about specific heat capacity.